A very good morning all of you. Today's lecture I will deliver the lecture on, as I have mentioned on the blackboard here, particle in one dimensional box. Let us proceed. The last topic of quantum mechanics of B.Sc part 3, we are going to calculate the value of psi x. The value of psi x, the value of psi, it can be calculated. It is depending upon two important conditions here, dependent upon case first, in absence of electric field. In this case, we will modify Schrodinger wave equation in such a conditions, in such a situations, in such a position. The particle will be known as, that is, a free particle here. Regarding to the derivation of this one value of psi x, next case associated with in presence of electric field. I mean to say that what will be the modification of Schrodinger wave equation here. By applying two important conditions, we will calculate the value of psi x, the numerical value I have mentioned on the blackboard here. In our previous lecture, we were expressing. Let us discuss about, that is, of case first here. In case first here, the complete Schrodinger wave equation, in absence of electric field, one can write as delta squared psi plus delta squared psi plus delta y square plus delta squared psi, delta z square plus 8 pi square a upon h square e minus v psi is equals to 0. In that is of x direction, I mean as per title, as per heading, in one dimensional, y and z direction will be is equals to 0, and equation number 1 takes the form of delta square x upon delta x square plus 8 pi square m into e minus v upon h square is equals to 0. Based on the case first, I am drawing the diagram here in the form of, that is, a very small box here. In our previous lecture here, we have also, it can be explained case first, and that is of case second here. Case first, we assume that denote in absence of electric field, and case second denote in presence of electric field. Let us assume here, I am considering here just a particle here which is moving between the distance x is equals to 0 to x is equals to a here. Students generally get confusion, students, about these two figures I have mentioned on blackboard here, a small box and that is a big box. You need not to be stressed, dear students. It can be explained. The simple box denote the moment of this one particle in absence of electric field. Larger box, which is modified name as, that is, a potential well. So you need not to be confused about small box, big box here. Small big box show the cases, that is the first, in absence of electric field here. I am taking very small particle here having the mass m, and the overall activities which is moving from this one side to, that is, the right hand direction to the left hand direction, having the distance, that is of x is equals to 0 to x is equals to a. It will move from x is equals to 0 to, that is, of x is equals to a. A small box show the condition of in absence of electric field. When no electric field is applied, particle the moment of the activities of the particle, such situation of the particle will be known as that is of free particles here. I mean to say, particle is moving having the mass of this one, that is of a mass particle which is moving between x is equals to 0 to that is of x is equals to a. It shows the case first in the absence of electric field. What will be the modification, changing form of Schrodinger wave equation here? I mention here equation number that is of 2 here. Now let us discuss about that is of case second here. Case second here, that is of in case second, that is of in presence of that is of electric field here. Now let us allow to put down the small particles having the mass that is of small m. Now put down this one small particle, it is now accelerated between x is equals to 0 to that is of x is equals to that is of a. This big box, large box is act as a role of potential well here. This small box shows the condition of in absence of electric field, and that is of this big box show act as a potential well here. This potential well now further divided into that is of 3 parts here, that is of first, third, and that is of second. My right hand direction part is divided a first, last part divided by that is of and symbolized by that is of second, or mid part denoted by that is of by 3 parts, by 3 numbers also here. The particle is now moving between x is equals to 0 having the mass x is equals to 0 to by keeping a distance x is equals to a. This potential well is now divided into, once again repeat, 3 part 1, part 2, and that is of part 3. Having the limitations, boundary limitations, the activity, the moment, the acceleration of this particle move from right hand to left hand directions, collide and accelerate back. Its motion will oscillate, will accelerate between the boundary condition x is equals to 0 to x is equals to a. Now I want to express you about its quantum mechanical conditions regarding that is of part 1 and that is of part 2. Dear students, in this part 1, since electron is present here between the boundary lines here x is equals to 0 to that is of x is equals to a, so it becomes essential the possibility for finding out of the electrons will be equals to that is of in part first and second will be equals to 0. Psi square density will be equals to 0, and similarly next one point psi square d torque will also be equals to 0. The same quantum mechanical conditions will be applicable as that is of in part second also. Listen to me once again. Electron or particle which is moving between x is equals to 0 to that is of x is equals to a, and the potential well in which 2 parallel larger that is of electrodes are connected here. We analysis about the activities, the mobilities of electronic phenomena here. So obviously it is evident, since electrons particle is moving between the 2 largest limits x is equals to 0 to x is equals to a, keeping a distance x is equals to a. So I would like to explain you in part this one and this part first one and second. Psi is equals to 0, psi square is equals to 0, psi square d torque is equals to 0, and you know psi square that is of dt probability for finding out the electrons or particles, since particles present inside of the parallel larger electrodes plates here. So automatically it becomes essential the similar condition, the same condition will be applied in part 1 and that is of part 2. because in this part first and second electrons or particles are absent. Now we have to focus, we have to applicable, we have to centroid overall the moment of the particle. We will, that is of present our lecture on particle and its value inside of, that is of particle 3. Rest derivation of this particle we will derive, that is of tomorrow. Thank you very much.